For our microcontroller technique project we implemented a little voice recorder on the MSP432. The sound is recorded with the little microphone and it is played with the buzzer. The sound quality of the buzzer is not very good, but if you listen precisely you can hear the recorded audio. To improve the sound we stick a little transparent sticky tape on the buzzer. You can start the record with pressing the S1 button, and when the record is finished you can press the S1 button again to play it. So let's test it.
Hello world, this is a test audio for the MSP432 voice recorder.
The volume of the audio output was increased afterwards so that it was audible in the video. The real output is very quietly. In the example the record length was set to 5 seconds. The maximum record length is 16 seconds because the SRAM size of the MSP432 is just 64 kilobyte. The sample frequency is 4 kHz, which means that 4,000 values are saved every second. So each second of record takes 4 kilobyte of memory, so the maximum length of a record are 16 seconds. The audio input is recorded by the microphone of the MSP432 booster pack. The signal is received via port 4.3 and the analog digital converter. Channel 10 is used to get digital values which represent the amplitude of the membrane. Since the recorder uses only an 8-bit resolution to save memory, the values received at a time are between 0 and 255. The sample frequency is 4 kHz so that 4,000 values per second are saved. According to Nyquist's theorem, the recorder can detect a frequency range of 2 kHz. After the full time duration is recorded you can play the record. To generate the audio output the microcontroller uses the buzzer at port 2.7 which is controlled by the timer 0.4. The timer is running in up mode, that means that he counts to a specific value repeatedly. Moreover the timer is configured with output mode 7 reset set, which causes the output voltage signal to be reset when the timer reaches a second specific value. Doing so we are able to generate a pulse width modulation signal, in short PWM signal, to modulate the recorded audio to the buzzer. The carrier frequency of the PWM signal is chosen as 100,000, so that it is not audible and does not mess up the real output. The information of the recorded audio is represented by the width or the duty cycle of the PWM signal. The width is defined by the second value. The following example shall clarify the preceding. The microphone has recorded a raw value of 180 through the 8-bit analog digital converter. First of all, the duty cycle is calculated by making up the ratio of the input value 180 and 255, because 255 is the maximum of an 8-bit analog digital converter. The timer, which controls the buzzer output, is run with the frequency 48 million, so to realize a carrier frequency of 100,000, the timer has to count to the upper limit of 480. This is the value of the CCR0 register. To set the needed duty cycle of 0.706, we multiply 480 with the duty cycle and set this value as the CCR1. Because the sample frequency was 4000, new values for the reset set limit, which is the value of the CCR1 register, have to be set with the same frequency and not with the carrier frequency.